Hey, welcome back. Don't forget that Friday night, your first Edfinity homework is due. If you didn't register for Edfinity yet, register for Edfinity. Yes, ma'am. How many homework questions?
No, I have a question.
We have a question about the homework. Oh yeah, we'll do those at the end, and then I'll do them again on Friday as well. So you can always also send me an email right from Edfinity and say, can you help me with this? Right now, probably like from Monday stuff, you could only do numbers 1 through 6-ish. And then the rest we're gonna work on Wednesday and Friday. Yeah, so that's the Edfinity due Friday. We're gonna do the definition of a limit today. Oh, if you have to miss a class ever, I'm recording sessions and posting the recording after a class. So if you miss a class, you can always go back and see that recording. I'll post it right in the announcements where I posted the notes. Remember how on Monday I posted an announcement afterwards that said, here are the notes from today, go ahead and do this. I'll post a link to the recording there as well. I didn't do it Monday, I'm starting today. That's what I decided yesterday. I'm starting today. Yeah, like on D2L. Let me see if I can show you. What's this for this one? So that our D2L page right here where the announcements come up. So like on Monday, I posted the filled in notes and told you about the content and said, here's the Edfinity. So today I'll post another one that has the completed notes that we fill out and the link to the recording. It usually like, oh, this says I posted it at 11:42 a.m. That's impossible. I don't know what this time zone thing is doing, but it'll be like half an hour after class, depending on the day. Yeah. Because it has to upload, so however long that takes. Okay, so we're going to talk about a limit. So last time we talked about sort of average velocities and we talked about instantaneous velocities. And we said we could estimate an instantaneous velocity by making the 2 points get closer and closer together, right? So what we're doing is we're taking one value and seeing what happens as it approaches another value. That's kind of what a limit is. So a limit is the y value. A limit is always going to be a y value. A limit is the y value a function approaches from both the left and the right side of a given x value. Okay, so a limit is going to be the y value, the output of the function that the function approaches from both the left and the right side of a given x value. Here's the things you want to think about. Nowhere in this definition does it say what happens right at the x value, right? It says what's happening on the left, what's happening on the right, and then we're going to see what happens at that, right? So we don't care what happens exactly at our x value. We just care on the left of it, on the right of it, okay? And we're going to look for the y values. We're going to have the x values. We're going to look for the y values. Today, we're just going to use graphs and tables. And then Friday, we're going to use equations and see how we deal with that kind of thing, okay? So let's start with this example. And this notation down here is how we talk about a limit. So this is the notation for limit. So it says limit x approaches a f of x. So a is the x value I'm trying to get close to. F of x is the function I'm using. The output of this will be a y value, okay? So I want you to start with these 3 graphs here. All 3 of these graphs look really similar, right? These first 3 graphs all look really similar. What would you say is the only difference in these first 3 graphs? Those holes, those open circles, what's happening to the function right at x equals -3, right? So in this first graph, it just goes right through at -3. In the second graph, there's this hole at -3. And in the third graph, there's a hole that's filled in somewhere else, right? So at -3, these graphs look different, but on either side of -3, they look exactly the same, right? Okay, so let's answer this first question. F of -3. So f of -3 for these 3 graphs. -3 is my input, it's my X value. I'm gonna go to that X value and look for the Y value. So in this first graph where it goes right through and makes a whole parabola, what would you say f of -3 is? 4. Yeah, it's this point right up there. 4. Okay, how about in this second graph? What would you say f of -3 is in that second graph? Yeah, it doesn't exist. There's a hole there, right? There's no filled in dots anywhere in that at -3 in that second graph. So we're going to say that f of -3 in this second graph does not exist. Okay, how about in this third graph? What will you say f of -3 is in this third graph? 1, because when I'm looking for the output, the function value, I look for the filled in dot. Okay, so when I'm looking for the output or the function value, I look for the filled in dot. Okay, let's go back to the definition of the limit. A limit is the y value a function approaches from the left and right side of a given x value. Okay, in this function right here, as I'm getting towards -3, remember, I don't care what happens right at -3, but as I'm getting towards -3 in these 3 graphs, what are the y values approaching? 4. So these limits are all going to be 4, even though the graphs look different, right? These limits are all going to be 4, even though the graph looks different at -3. But again, I don't care what happens right at -3. I only care on the left and right sides. Yeah, so I look at, here's my x value, -3, and I'm looking at what happens on the left side of -3 and what happens on the right side of -3. And because I see both of those arrows are pointing towards y = 4, that's my limit. Even though in some functions there's a hole at y = 4, in some, I'm sorry, at x = -3. In some functions, there's a hole with a filled in dot somewhere else. So I don't care what happens right at that x value, just on both sides of it. Okay, what's different about these last 2 graphs? They're broken, right? When I'm going on the left side of 3 and when I'm going on the right side of 3, different things are happening. These graphs, these last 2 graphs are broken. Let's answer the easy question first, right? If I look at this graph here, f of -3 is going to be 1. I look for the y value. Oops, f of -3 is going to be 1. Okay, and this final graph, f of -3 is going to be 2. So when you're finding the function value, f of x by looking at the filled in circles. When you're finding the limit, the filled in circle doesn't really matter, right? It just matters what happens on the left, what happens on the right. Okay, so let's do this graph. On the left side, the y values are approaching 4. On the right side, the y values are approaching 1. Go back to your definition. A limit is the y value a function approaches from both the left and the right side of the given x value. Yeah, so in this broken graph, because the left side is approaching 4 and the right side is approaching 1, we're going to say that this limit does not exist. Same thing happens in the last one. The left side is approaching 4. The right side is approaching 1. We're going to say this limit does not exist.
Is it always the case that the limit is not exist?
If the graph is broken, the limit will not exist at those points. Yeah. So the limit can only be one number. Absolutely. Yep. The limit can only be one number. Okay, so here we say, when does a limit not exist? So how would you tell me? What should I put here to say, when does a limit not exist? Yes, sir. Yeah, if the left and right side are not equal, right? If the left and right side are not equal. Okay, so here we could say, if the graph is broken That's our slang word, yeah. And then if we say, if the Y value approached from the left side is not equal to the Y value approached from the right side. And I want you to pay careful attention to this notation here, this limit as x goes to -3 f of x. So this is the x value you're looking at. This is the function you're looking at. The output, what the equals, is going to be the y value. But remember, when you're approaching -3, that means you're approaching -3 from the left and from the right, and those two numbers have to match. Okay, so when you're doing a limit approaching -3, you're approaching from the left and from the right, and those two numbers have to match. So a limit will not exist if the graph is broken. If the y value approached from the left side is not equal to the y value approached from the right side. Another thing that could happen is maybe the function doesn't even exist on the left side, right? Like if we're looking like at a square root function. If I look at the square root function like this, and I asked you what's the limit as x goes to 0 of this function, you would have to say from the right side, it's approaching 0, but from the left side, there's nothing there, right? So you would have to say does not exist because it's not defined on the left side. For the numbers smaller than 0, this function is not defined. Okay, so then what we might say is, let's talk about one-sided limits. Like maybe we only want to know what's happening on the right side of our number or what's happening on the left side of our number. Because if we were doing that square root function, we might want to know that as we approach 0 from the right, it gets close to y equals 0. And as we approach 0 from the left, it doesn't exist. That's good to know about functions, right? If we go back up to these two graphs at the end here, we would say from the left side, it's approaching 4, and from the right side, it's approaching 1. And those are good properties about the graph to know. So we call those one-sided limits. Okay, so a one-sided limit is the limit of a function, the limit a function approaches as you approach a given value, given x value, from either the left or the right side. So a one-sided limit is the limit, or the y value, let's say y value here. A function approaches as you approach a given x value from either the left or the right side. And here's the notation. So what do you notice is different about this notation than the first limit notation we had? It's got those little plus or minuses in like the exponent spot, right? It has these little pluses and minuses in the exponent spot. Those little pluses and minuses tell us I'm only looking at a one-sided limit. The minus means that you want numbers to the left of 3 or slightly smaller than 3. The plus means that you want the numbers from the right side of 3 or slightly larger than 3. Okay, so if I'm looking at this graph that they gave me and I do the limit as x goes to 3 from the left. So I'm looking at numbers that are slightly smaller than 3, like 2.9, 2.8, and I'm saying what y value does the graph approach? And it approaches -1. Then I do limit as x approaches 3 plus, or limit as x approaches 3 from the right. So I'm looking at numbers that are slightly larger than 3, like 3.1, 3.2, and I see that the y values are approaching 2. So those little pluses and minuses tell you a little bit smaller to the left, a little bit bigger to the right. Notice that I didn't care at all whether I had an open circle or a filled in dot, right? I didn't look at that at all. That only matters when you're finding the function value. If I asked you what is f of 3, you would say 2, because you look for that filled in dot right there at 2. What if I asked you this limit? Yeah, Jake says does not exist. These two sides are not meeting each other. When I don't put a little plus or minus there, I need both sides to go to the same spot. If both sides do not go to the same spot, I'm going to say does not exist. Oh gosh. Someone's calling me on Teams. Okay, so I want you to take, I don't know, 2 minutes. What do you think? You can do it in 2 minutes? 3 minutes maybe. And try to find these values. Notice some of them are one-sided limits with the pluses or minus. Some of them are just regular limits. Some of them are function values. Talk to your neighbor and see what you get for these values, okay? Okay. Limit as approaches, x approaches -2 minus. Here's -2. Minus are the numbers over here on the left-hand side of -2. So I am traveling on this line up to the y value of 1 at -2. Okay, let's see. I'm going to do -2 plus now. So here's -2 plus are the numbers on the right-hand side of -2. I'm traveling on this curve towards the y value of -2. Okay, now I'm going to do this third one that says the limit as x goes to -2. What did we say above there that says when does a limit not exist? When the two sides don't meet, right? When I'm on the left of -2, I went towards 1. On the right of -2, I went towards 0. There's this big old break at -2. So I have to say does not exist. Okay, let's see. Tell me your name. Mary. What do you think for this? Mary says for limit as x approaches 1 f of x. What did you say? 1. Mary says 1. Agree or disagree? Agree. I like that, Mary. Limit as x approaches 1 is 1. Look, here's 1. I'm coming from the left of 1 and the right of 1. They're both approaching that hole. Do I care that there's a hole there? No, I only care that those two sides are going to the same place and that they're meeting together. The hole doesn't matter at all. Okay, let's see, 0. Don't tell me yet. I gotta pick somebody. Who am I gonna pick? Come here. What do you think? Nabil says -2. What do you guys think? Agree or disagree? -2. They agree with you. Yeah. Okay. So at 0, here's 0. On the left of 0, I'm coming towards -2. On the right of 0, I'm coming towards -2. We're going to say -2. Great. Nabil says -2. Okay. All the way in the back corner. For this limit as x goes to 3 minus 5. What's your name? Tatiana. Tatiana says limit as x approaches 3 minus. Tatiana got a hard one because it has that minus again. What does minus mean? From the left side of 3. Okay, here's 3. I'm not even writing. Here's 3. Here's the left side of 3. I'm traveling on this curve up here towards 5. Yeah, I like it. Okay. This 3 minus? Yeah, here's 3. I'm traveling towards 3 from the left. So my Y value is getting close to 5. It turns out that if I'm traveling towards 3 from the right or towards 3 from both sides, this limit is always going to be 5. So I could add in here limit as x goes to 3 plus f of x. That's 5. And I could just say limit as x goes to 3 f of x is also 5. So if your function is like if we look at this part of the function, it's nice, right? When I say nice, I mean there's no holes, there's no broken spots, it's just traveling nice and, great through there. Then the limit from the left or the right or both is just going to be the value of the function. Same thing happened at 0, right? At 0, this function is nice. There's no breaks, there's no holes. So if I was to do the limit as x approaches 0 from the left, or the limit as x approaches 0 from the right, or the limit as x approaches 0, they would all be the same and they would be that y value -2. Okay, let's see who comes next. I'm doing limit as x approaches -1 f of x. All right, gentlemen, all the way in the back. What's your name? What's your name? Yeah, what's your name? Adrian. Win. You guys agree? -3. Adrian and Win say limit as x approaches -1 is -3. Agree or disagree? Agree. Yeah, good job. Okay. Limit as x approaches -1. Here I am looking near -1. It's one of those nice places, right? Like, don't overthink it. If the graph is nice there, you don't have to think very hard. So we're going to say -3 right here. -3. Okay. Look, another nice place. Limit as x approaches -3. Here's -3. Another nice place. Tell me your name. Because you have a Mickey Mouse hat on and it's my favorite place in the world. So Matthew, what do you think of limit as x approaches -3?
X approaches -3, it looks like it goes to -2. Or no, wait, as x approaches -3, it goes to
0. Matthew says 0. Agree or disagree? Agree. Yeah, here I am. It's really nice there. 0. Okay, we left the easy ones for last. When I'm doing f of a value, what am I looking for? The filled in circles, right? The filled in circles. Okay, so f of 1, here's 1. The filled in circle happens at -2. Great. Okay, here's -2. The filled in circle happens at 1. Okay. I'll give you a second to write it down if you didn't get to. I post this later, so you can always do it then too. Okay, this one says create a table of values of this function, square root of x minus 1 over x minus 1, corresponding to values of x near 1. Then make a conjecture about the value of the limit as x approaches 1 of this function. Okay, here's the thing. If I look at this equation and I look what happens near x equals 1, if you try to plug 1 into that equation, what happens? Yeah, you get a 0 in the denominator, right? 1 minus 1 makes 0. 0 in the denominator should be like light bulbs screaming in your head. Don't do that. Dividing by 0 is awful. So you're thinking to yourself, something weird is happening. There might be a hole there. There might be an asymptote there. Something weird is happening. So we can do this a number of ways. We can make a table, pick some numbers really close to 1 and see what they're approaching. We can make a graph and see if we can tell from the graph what it looks like at 1. I'm going to do both of those things in Desmos. Okay. You can use your graphing calculator. You can use Desmos. I'm going to do both of those things in Desmos. Desmos. Okay, I'm putting in my function. F of X equals fraction square root X minus 1 over X minus 1. Okay, I have typed in my function. I'm looking at what happens to this function near X equals 1. Okay, near X equals 1. Look, if I go directly to X equals 1, Desmos tells me that this function is undefined, right? It tells me there's a hole there. Yeah. What Y value do you think this function is approaching near X equals 1?
0.5.
Yeah, 0.5, 1/2, right? If I asked you what the limit of this function is as X approaches 1, you would say 1/2, 0.5. Yeah, just from the graph, that's easy to see. There's no break there, right? It's not two different sides. There's no break. So I can see that from my graph. If I put in numbers that are really close to 1, like 0.99 and 1.01, I can see that these Y values are really close to 1/2, right? Are really close to 0.5. If you're doing this in your calculator, you type that equation in, you look at the graph, hopefully you can see 1/2. You might have to zoom in and change your window a little bit. You can go to the table and look at table and do it that way, right? But I'm going to get 1/2. So if I'm conjecturing what this limit is, I'm going to say 1/2. It's important that you look at numbers from both sides. Don't only plug in numbers smaller than 1 or only numbers bigger than 1. Plug in numbers on both sides to make sure they're both getting close to the same thing. If you only use one side, that might be a trick question or something. Oh gosh. Oh dear. There we go. Okay, so here what we said that the limit as X approaches 1, we think is going to be 1/2 or 0.5, because there was this hole here, but on the left-hand side and on the right-hand side, these Y values are approaching 1/2.